Okay, so today is called Complex Numbers B. And remember, x-intercepts are great, but what if it doesn't intercept the x? Then it's kind of like this, and it ends up being an imaginary number, which means a negative underneath the square root. Okay, so everybody try this one. I can guarantee you, if you can factor it, you should, but most of these are not going to factor. So if you can't factor, 2 words, quadratic formula is the way we actually should say it. Quadratic formula. Okay, because a quadratic equation, just to clarify, this is a quadratic equation, as opposed to a quadratic formula, which is the big one, x equals negative b, blah, blah, blah. Now, the part that people miss the most is the b squared minus 4ac. Do you remember me telling you to start with that part? That is the most commonly missed part. 4b squared minus 4a, which is 1, c, which is 2. So that means 4 minus 8, which is negative 4. Underneath here, I'm telling you, that's the place, like 9 out of 10 times people make a mistake, it's that number's wrong somehow. It's usually because they mess up a negative and they think, oh, it's a minus, even though there's 2 minuses, they end up subtracting the thing. But if there's 2 minuses in it, of course, you have to add them. Well, in this case, it ended up being 4 minus 8, which is negative 4. And so there you have it. Did you know how to simplify it from there? Raise your hand if you feel confident that you have simplified it correctly. Okay, good. I'm going to go one at a time. Die of Destiny. Who should I call on? Oh, I got more up here. Don't worry. Okay. Row 2, person 4. That's Sam. Tell me how to start. Which is? Yes, you could say square root 4, square root of negative 1, and then it would be 2i. There you go. Good. Okay. So that's 2i. Does that make sense to you? All right. So keep going from there. Then I bet you factored.
Take the 2 out. So that it's just, or wait.
I'll clean this up a little bit.
So then it's just going to be I, over 2.
You're making a classic mistake. Try to figure out what goes in this parentheses. When you take a 2 out of both of them, did the 2's just disappear? No. What you're really doing is dividing them both by 2. And so therefore, 2 divided by 2 is a 1. You still need the plus and minus. And the 2 divided by 2 is a 1. 1 plus and minus I on the inside. Okay. All right. Now what? And there's your answer. You get how a 2 came out of here and a 2 came out of here, but when we take a 2 out, you have to leave, if you're going to, the whole 2 is just going to disappear, you have to leave a 1 behind. Because what's really happening is you're dividing by 2. Okay, good. So those are imaginary roots. They're really not x-intercepts. It's kind of a misleading thing, because if it had intercepted the x, they would have been real. They wouldn't have needed the imaginary thing at all. So they're not really x-intercepts. They're the other 3 things. They're roots, they're zeros, and they're the solutions. Now, to make sure you really get, what do they do? What's the point of these things? If you stick this in for x, what will the equation equal? That's the point of what they're called. What are they called again? They're imaginary roots, but they're the roots, or the what? The starts with a Z, say it. Zeros. They're the zeros. So what do you think they do to the equation? They make it equal 0. Let me prove it to you. Watch what happens when I actually put in 1 plus, I'm not going to put 1 plus and minus because it's 2 answers. I'll just pick 1 plus I. So if I stick that in here for x, it's 1 plus I, and I square it. And I go 2, and here's the other x. And what am I supposed to put in? 1 plus I. And then I have plus 2. All I just did is replace my x's with this magical thing what's going to end up happening is the whole thing is going to add up to 0. It will. You don't think so?
I'm wondering, how do you get 1 plus I when it's -2?
Would you agree this is 2 answers, Nemo? And one of them's 1 plus I, and the other is 1 minus I. That's what that means. So I just chose one of the 2 answers. I chose the 1 plus I, and I'm putting it in for x. And what it's going to do is the x-intercepts are where y is 0, right? So it's going to make the whole equation equal 0 when I stick in this. So I'll prove it. I got to go kind of fast, though, because it takes a long time. 1 plus I and 1 plus I, and then minus 2 times 1 plus I, and then plus 2. And then next level is I square this thing out, FOIL it out. 1 squared is 1. And then outside is plus a 1i, and inside is plus a 1i. And then the last is plus I squared. What's that? What's special about that? I squared is really -1, right? And then I'm going to multiply this all out, -2, and then -2i, and then plus 2. There. And when you actually add all of this up, it's going to end up being 0. Watch. Watch what happens when I take those 2 i's and make positive 2i, and that negative 2i. What happens to them? They're gone. And then what happens to this -2 and this plus 2? They're gone. And then what happens to I squared? It turns into, which cancels out the, and then they're gone too, and it all equals 0. That's what these are. These are not things that will make my equation turn into 0. The thing that they aren't is x-intercepts, because the whole point is that they don't touch the x-axis. Because if they had, I would have had 2 normal answers that didn't need imaginary numbers. All right, so you're still just solving quadratics. It's just that in the end, on our last test, what we would have done is as soon as we realized that b squared minus 4ac came out to -4, you could stop. And remember that? You could just like, oh, it came out to a negative. So, oh, no answers. Now you have to keep going and figure out what the rest of it is. All right, so this one, it says to graph them. One of these 2, I think actually, let's just do this one. How do I graph that one? Some thoughts about how to graph it. Maybe you could use an XY chart. Maybe you could find the vertex. If you can factor it, you should. But that negative in front makes it a little tricky. Maybe you should take the negative out. That negative means it's an upside down parabola, right? Lots of little things you should be thinking about in this. So, anybody had any success in factoring it? If you can factor, you should. You take a -1 out, you get x squared plus 4x plus 3. Does it factor? A few people are saying yes now. -1, x, and what multiplies to 3? A 1 and a 3. And I just got to check and see if that actually works. First, make x squared. Outside and inside makes 4x. Last makes 3. Hey, it's working. Hey. So, I now know it touches at -1 and -3. Because that's the root for this, that's the root for that. -1 and -3. And then, man, it'd be really nice if I knew another point. I do. It's the what? Y-intercept. The y-intercept is -3 because it's where x equals 0. So that's gone and that's gone. Y is -3, touches down here. Now can you kind of reconstruct where this thing must be? Did it have any stretch factor or not? Does not have a stretch factor, so therefore it must hit right there, and it's a parabola that goes right through all those points. So generally goes like that. Yay. Okay. How did I get the what? There's not a -2. Oh, you mean the vertex?
Oh, yeah, you just
I just knew that the vertex had to be up there because it's an upside down parabola. And I knew that normal parabolas only go over 1 and up 1. And so since this doesn't have a stretch in front of it, okay, so anyway, now, would this one give me imaginary roots? No, because they're real. I can see them. They touch. This one, does that factor? Let me think. I don't think so. Now, just because it doesn't factor doesn't automatically mean that it's not, that it's going to be imaginary. But I can tell you this, since it touches here at y equals 2, and I know it's got to be an upward parabola because there's no negative in front, and I should probably figure out the vertex of it quick. Remember that from the last unit? Complete the square for vertex form. Everybody do the vertex CTS, complete the square. Move that 2 over and do that half and square thing. Find the vertex. Can't afford to forget these things. If we don't take a minute and practice it right now, you'll probably be gone in about 2 more weeks. You'd forget how to do complete the square. And why would that be bad? Because the final's coming. The final's going to have complete square on it. Would you walk me through the half and square process? Half of -2 is -1. Then what? +1 plus 1. How about? Excellent. What's that do? Close. Yep, and then keep going. That part right there. You're right, +1. My bad, I thought it was going to be something else. There. Okay, so what does that tell me about the vertex? 1, 1. So the vertex is right there. And do you get that this thing cannot be going this way?
Yeah.
Because it doesn't have a negative in front. So it must be going this way. See how logically we know where that thing is? And that's the kind that's going to have imaginary roots. Because it isn't touching. Okay. Let's, what is the difference? Square root of 16. Sadly, a lot of kids have gotten in this pattern where they go, oh, that's the kind of problem that ends up with 2 answers. So I'm going to put plus and -4. And it's not. The square root of 16 is just 4. You do it with a calculator. Type in square root of 16. It won't say 4 and -4. It just says 4. Okay? Over here, when you do square root on this, you end up with not x equals 4. That's wrong. And so value of x equals 4, and that's how you get 2 answers. It's not because the square root comes out negative. It's because you have a variable being squared. So if a 4 works, a -4 has to also work the same way. So x equals 4 and x equals -4. All right, so we're just reminding you that that's what the plus and minus, that's why there's a plus and minus in that quadratic formula, is because of this. It's not because square roots have a positive and negative answer. It's because of this whole thing with the absolute value. All right. So if you were to actually graph them, you will get this. If you just graph y equals x, and if you graph y equals the square root of x squared, your calculator knows that there's 2 answers for that, a positive and a negative. Get if I put in a 1, it'll come out with 1. But putting in a -1 also comes out with 1. So whether your answers are, there's 2 answers. It's almost like you're drawing a line through like this. There's 2. So like you can prove with a calculator that the square root is not when you take absolute value of something, which is what this is, it proves to you that that is an absolute value graph. Get how normally square root graphs look like this? This is not a normal square root. So how come it looks like an absolute value? Because the answer to that is the absolute value of x. I'm just trying to prove to you that that's why when you go like this and everybody says it's x, that's why they're wrong. Because if you graph this, it'll tell you what the answer is, and the answer is actually absolute value of x, because we know what the absolute value looks like. Okay, moving on. If you were going to do this one, there's a hard way and an easy way. The hard way is to use the quadratic formula. It's actually kind of easy. Because you know A is what? 1. What's B in this case? 0, because there's no B. And there's a C of what? 4. And you can just do that. That works fine. But there's a faster way than the quadratic formula. Yes?
What you do is subtract both.
Yup.
Square root of x.
Square root, and then
The absolute value.
thank you for remembering the absolute value. If you hadn't, I would have had to.
But isn't that negative 4?
Wait. What's the square root of 4? Oh, sorry, you're right. What's the square root of negative 4? 2i. So that doesn't stop us anymore. In the old days, we'd say, oh, can't do it. Now we just keep going.
And you do x equals negative 2i.
Yep. Negative 2i and positive 2i. Now, what would have happened if you'd have gone through the whole quadratic formula? You just got the same answer. It's fine. Quadratic formula always works. That's the cool thing about the quadratic. But this way is a little faster than the quadratic. But if you want to just use the quadratic and you're good at it, fine. It'll work. Yes?
Why did you have to square root that, like after you subtract the 4? Because when you do like x squared equals 6. Oh, never.
Yeah, we still do. Yeah, we have to get rid of the squared. That's why we square rooted. All right, moving on. This one, this is right off the top 20, except now you got a negative underneath the square root. So when you take the square root of this side, you remember to do absolute value. Okay, give that a shot. Sir.
I was gonna say, can we graph negative 2i and
It's a good question. Imaginary numbers, they're imaginary. You can't see them on a graph. They're kind of like leprechauns.
they're there, but they're not.
They're there, but you can't see them.
That's not a leprechaun.
Follow the pot of gold. There is still pots of gold around.
I bet.
There is. It's just that they're not at the end of rainbows like they say on Lucky Charms. They're underneath the ocean.
Yep.
Back in the old days, there were so many ships sailing around, and back then they didn't have dollars for money. They had gold. And so everybody that travels nowadays, think about it. People carry money around, right? Or they have credit cards that take care of their money for them. So in the old days when people traveled around, especially like big groups of people, they'd have all their money on the ship. And then when the ship sinks, their money is in the ocean. And unlike nowadays money, which would just decay away after a few years, their money's still there, sitting in ships at the bottom of the ocean. An interesting new technology that they have a new technology, and this I think is going to totally change digging for gold. They can sense gold from satellites. So now they can aim a satellite at an area, and even if it's in the ocean, they can sense if there's gold there. It's not perfectly accurate yet. But it's just starting. So pretty soon they'll be able to go, holy cow, we just spent 25 grand to aim the satellite over here and take these readings, but now that we interpret these readings, we can tell there's a whole bunch of gold right there. And so they'll send out their ships and go down and dive and pull up big amounts of gold. Yes?
This is getting off topic, but like, if they find all this gold, isn't the amount of gold going to go down since there's really abundance of it?
You make a good point. When there's more of something, the value of it gets less, right?
Yeah.
So like if everybody only had, like one Jolly Rancher, they'd all be kind of precious. But then if I like dump a ton of Jolly Ranchers in the middle of the room, everybody's like, well, that they're not that big of a deal anymore. I can have tons of them. So you're right, but the amount of gold that's in the ocean really is kind of small. It's just intriguing because even the world's supply of gold is, it's fairly large.
Yeah.
So the amount that's hidden in the ocean in these little shipwrecks isn't going to really affect that much. The allure is just if you personally if you knew where the gold was, you can just swim out there and get it and take it and it's yours.
Yeah.
You know what I mean?
I said we had all these copper pennies and then get the money out for the copper.
The copper isn't going to be worth nearly as much as the gold.
Kind of we hide in the ocean.
If you, they can detect copper with this thing too, but again, nobody's going to be looking for the copper. Gold is what it's all about. And back then, the best thing they had was gold. Nowadays, what's more valuable than gold? True, diamonds are for the amount of weight they have. Diamond is much more valuable than gold. Platinum is more valuable than gold too. Platinum kind of looks a lot like silver. but it's less shiny and it's way more expensive. I don't even know why it's more expensive. Maybe just because it's harder to get, more rare. All right, so I understand you need to go. I need to get this answer for you real quick. You should have subtracted 36. And then when you took the square root, hopefully you knew his absolute value of x plus 2 equals negative 36. Then we go square root of negative 36, my bad. And then that's what? 6i. Then we're still not done because we've got to break it into two parts. My favorite way to do this is to write the two equations identically. Just take the absolute values off and write what you see. X plus 2 equals 6i. And identically, x plus 2 equals 6i. That way it's not hard to write the two equations, but you got to make a change on one little thing. What's that? This one becomes a negative 6i. That's the only difference between the two equations. That way the equations are so easy to write. You just make them identical, except put a negative on that one spot. Okay, then you just solve them like normal mini equations. Subtract 2 from both sides. That becomes x equals 6i minus 2. And then subtract 2 from both sides here. This becomes x equals negative 6i minus 2. There's my two answers. And yes, you can put those together and say plus and minus 6i minus 2. That is allowed. Any other questions? I saw a hand, but it's gone, so I'm assuming you're okay. Okay, good. All right, so let's jump to the assignment on this puppy. It is 7.5 complex numbers B, and I'm going to cut it down a bit for you because that one's probably a little bit too large for how much time we have left. I'm going to pause wherever my video thing is there. Okay, so here's the worksheet. Let's just make life a little simpler by eliminating the middle column. All the problems that are in the middle there just go away. Okay, so that one and that one goes away and that one goes away. And then down here there is no middle column. So we'll skip the ones on the right, the left-hand side. We'll skip the ones on the left. Okay, so this one gets skipped and that one gets skipped. And that's it. You can always save those other problems for problems you could do on the night before the test. If you want extra practice on this topic, you can go back and do those. The answers are all already done for you and stuff on the keys. So, okay, now one last thought. I'm guaranteeing you that next week the top 20 is going to happen sometime next week. It's 20 minutes. It's timed. And if you're not good at it yet, practice up. I do have that reward gold doubloon, except it's not exactly gold, for anybody who can get the 19, even if it takes you 3 retakes. I'm up for it if you're up for it. And I'd love to encourage you with that to get those things down. They're so important for the long run. All right, and that's all I have for you for today.